Hello everybody, hi, this is Mitch Bailey, and I'm here with Bailey's Heating and Air and Air Heroes, and today's subject I want to talk about CFM and airflow. So CFM, cubic feet per minute, what is it, and why does it matter? So your heating and air system needs to breathe, just like you do, and without enough air, your cooling and heating system will never work as it was designed or to its full capacity or potential. So CFM, cubic feet per minute, and it stands for cubic feet per minute is the volume or the amount of air that we're moving through the ductwork. And it matters because if we don't move enough air, we won't get the cooling or the heating out of it that we're supposed to. So your typical, let's say your typical system, let's say a 3-ton, needs so much air to deliver. So what we do is we have 400 CFM, per ton that we actually need to deliver. So if you have a 3-ton system, that's 3 ton times 400 CFM, and that's going to equal 1,200 cubic feet of air per minute, 1,200 CFM. So it's vitally important that we move this amount of air, because if we don't move 1,200 CFM, that we won't get the amount of cooling that we need out of it. And kind of give you an idea of how much air this is, let's do, just for fun, we're just going to do a little math. So a pound of 1 cubic foot of air, 1 cubic foot of standard air weighs 0.0807 pounds. And so a cubic foot of air weighs 0.0807 pounds. It's not a lot of weight, but it adds up. So, for example, we do the math, that same 3-ton unit, we needed 1,200 CFM, and we're going to multiply it times the weight, which is 0.0807 pounds, and we're also going to deliver it by, or multiply it by time, because this is cubic feet per minute, CFM, so we need to see what we deliver in an hour, so we're going to multiply 60. And what do we come up with? We come up with 5,810 pounds of air delivered over an hour for this 3-ton unit. That's a lot of air. I mean, it has to move a lot of air, and your system moving that air through needs really unrestricted ductwork. And let me explain ductwork for you a little bit here. So let's pull this up just a taste, and we'll draw some ductwork here. So here's a typical ductwork, and it's in your attic, and this is a cross section of your ducts. And so the air moving through that ductwork, it has to get to the place that's going to, the room that it's supposed to be delivering to, and down the center of the duct, it's fairly unrestricted, so it moves at a higher velocity and a greater volume. But as we get toward the outside of the ductwork, or the inside of the liners, it's because of the friction, it slows down. So on the inside center, we're moving quite a bit of air. Toward the edges, we're not. This is the reason we have to size it, because of this friction, and with flex ducts even worse. There's a little bit of turbulence in here because of the wire helix. So when we do it, we want to make sure that we size the ductwork correctly. And one of the things that we do for that is we have to watch out for our static pressure, because as the airflow moves through the ductwork, it's exerting a pressure against the outside of the duct, so just like if you blew up a balloon. And if that static pressure is too great, we're not going to move very much air through here, because it's going to slow it way down. So we want to size the ductwork appropriately for the amount of air we need. Now, a lot of people say, well, how do you know how much air a room needs? Because, you know, I could just guess at it, but that's not very good. So what we do is we do a load calculation on the house, and we come up with just like this. This is a typical house, and we have like a family room. So here's your family room, and this family room, after we did the load calculation, says I need 160 CFM for this particular room, and the duct size coming to it would the computer designs it automatically for me. I just draw where the duct goes, and then it automatically sizes it for me. But this could be like a 7 or even an 8-inch duct. And then this bathroom over here, this takes 27 cubic feet of air per minute. So this would probably be a 4-inch duct. And I say probably because I've done this thousands of times, and each time I do one, you know, I can pretty much size it just off of what I know, but I still use the computer program so we get it accurate. Then once we've measured, or we've put the ductwork in, we know what size it is, we have to tweak it, because the ducts leading to these rooms, they might go back to the unit. We'll put a damper in the ductwork up here and a damper on this duct up here, and so we can actually close and open the dampers. And the way we do that is we'll go in and we'll do a flow hood on it. This flow hood, as you can see from the flow hood, this is we can take this and I can make it measure the airflow in the coming out of the register, and then with another guy in the attic, so the airflow coming out of the register is blowing down in here. Robert here, who's taking this measurement, he can see this right here on this display screen, so he can tell the guy in the attic, hey, you need to open or close the damper more or less, so we can balance the system so that when we're actually doing it, we're actually delivering pretty much close to, we don't usually hit exactly, but we would be within 10% of this 59 that we need. Because if say this room was getting 100 CFM before we adjust the dampers, well, we're actually taking air from the rest of the house, and we want to push that air back the other way. Again, the computer designs this for me, so my ductwork will be sized appropriately. I don't have to actually go in and do that manually. And the same thing with the load calculation, it takes into account how the house faces, like this window up here and these French doors. So this room, even though it's smaller than this room, will need a little bit more air, and it depends how it faces. If this is facing west, then that's going to get all the afternoon sun, so it's going to need a little more cooling. And if you don't do a duct design, a room-to-room, if you just do a block load instead of a room-to-room load calculation, you won't have this information. You won't be able to do your job correctly. So that being said, my next one is going to be on static pressure. So I hope that you join me and we talk about the static pressure on your ductwork, because that's vitally important for the system to work right. All right, thanks for listening.